In the previous video, we were discussing the concept of null and alternative hypothesis. Remember that often the null hypothesis is the hypothesis we want to disprove. So, we want to prove the alternative hypothesis. Automatically, when you reject the null hypothesis, the alternative hypothesis becomes true. That is how we frame the hypothesis. Okay. This happens in most of the cases, but some case you have a risk, right. What is that risk? The risk is that the null hypothesis, you reject it, you reject the null hypothesis, but it is true, right. It is true and I reject it. So, what we have something called as a level of significance. This is an error, right. The rejecting the hypothesis when it is true is risky. Something is correct and I am saying it is wrong, I am rejecting it, right. Now, with 100% guarantee I told you, we cannot always say this will be true, this will not be true. So, what they do in statistics, they introduce what is called as a level of significance, a level of significance. What this means is, normally in statistics the two levels, accepted levels are 5% and 1%. Okay. Now, what is the meaning of this level of significance? You understand. Firstly, remember that when we talk of statistics, we mean probability. So, there is always a chance of error, we can never be 100% sure, right. So, when I say 5% significant level means, we will be using this in the tests. Okay. So, 5% significance level means that there is a 5% probability of rejecting a hypothesis, that is the null hypothesis, rejecting the null hypothesis when it is actually true. What does this mean? Let us say I make a statement that the average height is 155 centimeters of women in India is 155 centimeters. That is my null hypothesis, right. Now, I reject it at a level of 5% significance. That means, there is a probability that 5% of the women, it may not be true that in 5% of the chance that the average height is 155 centimeters. Okay. So, see the formal definition, rejecting a hypothesis which is true is risky. The level of significance is used for this, it is expressed as a percentage. Normally standard, as I told you, is 5% and 1%. A 5% significance means researcher is willing to take, I should be willing to take that risk, like everything in life is a risk, right. When you drive on the road, it is a risk, because we always have a risk of an accident. Okay. So, I am willing to take as much as a 5% risk of rejecting. Why I don't simply reject it with sampling evidence, with the samples I have collected, the null hypothesis when it happens to be true. Thus, the significance level is the maximum value of the probability of rejecting H naught when it is true, and usually determined in advance before testing the hypothesis. That means, if it is, you should say whether you want to test it with a 5% risk or a 1% risk. Impossible to do with 0% risk, because 0% risk means that error never occurs, which you can never say, because there will always be something or the other in your sampling which can give rise to an error. So, you decide what is the level of significance before you start. Okay. Now, we will see some examples, it will be very clear. And then we have a decision rule. What is a decision rule? A rule to accept H naught and reject HA, or to reject H naught and accept HA. So, how do I decide? That will be with the tests, which we will see soon, right. Now, let us see an example. Consider I am doing a quality test, how to frame H naught and HA. I am doing a quality check on a product. H naught, there are very few defective items. So, this actually is not correct, but then I have made HA also qualitative, most items are defective. If I do like this, right, because it is not perfectly quantitative, what are the questions which arise? How many items do I test and when do I reject? So, the manager tells you, let us say you are a worker on the shop floor and the manager tells you reject that batch if most items are defected, does not tell a number, right, and then or he says you can accept it if there are very few defective items. So, now I have to frame the rule. What do I do? Manager has not told me, so I say I will test 50 items and reject the batch if more than 5 items are defective. Clear? So, if I want to frame this correctly, I would frame H naught as in a batch of 50, that is known. In a batch, the defective items is equal to 5 and HA or is equal to 6, let us say, and HA, the defective items is less than 6 or less than 5, whatever number I want to put. So, now it is easy for me because I have already defined the quantity. Okay. So, now we will see what are the type of errors you can get in hypothesis testing, because significance level I told you, there is a level with which you are ready to risk an error. So, there are two types of errors standardly described. One is called as the type 1 error and the other is called as the type 2 error. So, what is the type 1 error? The first type of error is reject H naught when it is actually true. How am I rejecting? I am rejecting based on my sample size. I am rejecting it not chumma arbitrarily. I am rejecting it based on the sample size I have chosen and the values I am getting from sampling, based on that I am rejecting. Right. So, reject H naught when it is actually true. H naught is correct, but I am rejecting it. This is called as a type 1 error. Okay. This error is also denoted by alpha error. Also called the level of significance of the test. The level of significance is pertaining to type 1 error. A level of 5%, significance of 5% means I am taking a risk of 5% of rejecting H naught when it is true. So, when I reject H naught, what do? I accept HA. So, that is called as a false positive. I am positive about HA, but HA is actually not true. Why? H naught is true, but I am rejecting it. So, I am choosing HA because I have rejected H naught. So, it is called as a false positive. So, that is called as a type 1. Type 2, accept H naught when it is not actually true. That means, I accept it, but it is not true. This is called as a type 2 error. So, accepting a hypothesis that should have been rejected, then my whole result also will be wrong. This is called as a beta error. In both cases, my result will be wrong, conclusions will be wrong. The test incorrectly provides evidence against the alternative hypothesis. So, I am rejecting the alternative and accepting the null. So, I am rejecting something which is good. So, it is called as a false negative. False negative. So, these are the two types of errors you can have with hypothesis testing. So, I try to define the significance level based on the criticality of my problem. We have some two very nice examples. Now, see here, let us say there is a person who is being accused of murder, okay, a person who is accused of murder. So, my null hypothesis is person is not guilty. Clear? Person is not guilty. Right. This is a legal and human right. All the judicial system is based on the assumption that any person accused of a crime is innocent until the lawyers, the jury and the judges are able to prove them guilty by giving evidence. Any crime, you would have seen so many court scenes everywhere. So, my null hypothesis is person is not guilty. I need evidence to reject the null hypothesis. I need evidence to reject the null hypothesis. Okay. And the alternative hypothesis is person is guilty. Right. Now, I reject H naught, even though it is true. H naught is true means what? Let us say I am accused of murder, right, or some X is accused of murder, and my null hypothesis is X is not guilty, right. And now with my evidence I reject H naught. That means what? I reject the statement X is not guilty, which means X is guilty, right. So, what will happen? It is murder, let us say it is a death penalty. So, X will be sentenced to death penalty. What has happened here? X is actually innocent, right. So, I should have accepted H naught. H naught says the person is not guilty. I should have accepted it, but I rejected it, right. So, what is going to happen? An innocent person may be given a death sentence. This is very dangerous in this case. This is a type 1 error. Why is it a type 1 error? Because I am rejecting H naught even though it is true. Okay. So, if let us see that, so here what happens if there is a type 1 error, an innocent person will go to gallows. Let us say I make a type 2 error, that means person is not guilty. So, my hypothesis is X is not guilty. I accept it even though it is wrong, that is type 2 error. You accept H naught even though it is wrong, right. So, X is not guilty is wrong means what? What is the action you will take? X is not guilty means you will release X, but the statement X is not guilty is false. That means X is actually guilty. So, what are you doing here? A guilty person you are letting them go free in the type 2 error. So, in the type 1 error an innocent person is punished. In type 2 error a criminal goes unpunished. So, which is more dangerous? In this particular case type 1 is more dangerous. Why? Because an innocent person will unnecessarily face the death sentence. So, in the judicial system always we assume the person is not guilty and we should have enough of statements to reject it. All your evidence should show that the person is guilty, only then they will reject H naught. A beautiful example for alternative and null hypothesis. Now, let us take another case. A person goes for a medical test. So, nothing, I look at the person just on a routine checkup, the person comes for some checkup, and as a routine let us say you test the person for cancer, some cervical cancer. A lady comes and you do a pap smear test to detect cervical cancer, let us say. So, the person is healthy, everything. So, my hypothesis, null hypothesis is a person does not have cancer. Okay. I reject it. I reject it even though it is true. I am rejecting means what? Person does not have cancer is true, but I am rejecting it. So, I am concluding that the person has cancer. So, what is the error here? Error here, I am assuming a healthy person has cancer. I am not assuming. My tests, whatever tests I have conducted shows that I am assuming that a healthy person has cancer. So, what will I do? Now, I will make them go through further tests to see whether it is true. This is type 1 error. Now, let us take type 2 error. I accept H naught even though it is false. That means what, the person is coming, I do a test, I accept H naught. I say, okay, this person does not have cancer, but the person has cancer. So what happens? A person has cancer, but you are declaring them healthy. So you won't even go through other tests. See, normally what happens, whenever you have a problem diagnosed, the doctors will ask you to go through further tests. Right? See, supposing your ECG is perfect, your cardiologist will say go. Right? If it is slightly, there is some problem with the ECG, then the cardiologist will say, okay, go do an echo test, go do a TMT, everything. So in this particular case, type 2 error is dangerous, because there is a person who has cancer, you are assuming, or you are proposing that they don't have, not proposing or assuming, you are concluding that they don't have cancer. So a person with cancer goes untreated. Right? So what I want to demonstrate here is, there is no thumb rule in saying type 1 error is more dangerous, type 2 error is more dangerous, etc. It is based on how the hypothesis, both these hypotheses is what we normally do in medical and judicial system. In judicial system, as I said, we always assume the person is not guilty. In medical system, we always assume the person has some issue, doesn't have some issue, because if a healthy person comes. Right? So whether type 1 or type 2 is more dangerous will depend on the problem on hand, on the research problem on hand. So whatever we discussed, it's in a compact table here. H naught is true. Okay. So I accept H naught. It's a correct decision because it is true. Right. H naught is true, but I reject it. So I have an error, that's called as alpha error. Next, H naught is actually false, but I accept H naught. That means I think it is true. That's called as a type 2 error or beta error. H naught is false, and so I reject it, correct decision. So you have 4 combinations between rejection and the decision. 2 of them are correct decisions and 2 will give you errors. We can control type 1 error by just fixing it at a lower significance level. So instead of using a significance level of 5%, use a significance level of 1% in your test. So that means that there is just a 1% probability that you are rejecting H naught when it is true. So all your tables, testing tables, we will see so many tables in the coming videos, they are all based on type 1 error, minimizing type 1 error. Okay. So an error of 1% you can fix instead of 5%. With a fixed sample size n, when we try to reduce type 1 error, the probability of committing type 2 error increases. Both types cannot be reduced simultaneously. So based on the problem, you decide whether type 1 or type 2 error is more serious. I gave you 2 instances where in one type 1 was more serious, and in the second case where type 2 was more serious. So you decide, if type 2 is more serious, then type 1 you take with 10% significance level. But if type 2 is more serious, 1 is more serious, then you take a 1% significance level. So there is a trade-off between type 1 and type 2 error, and the choice is made depending on the cost of each error. Cost means the price you have to pay. What will be the effect of a type 1 error? Will an innocent person be sent to a death sentence? Will a person with cancer be rejected? Or will the healthy person be declared as cancer? So you have to decide on that. Now, so now you are very clear. We saw some statistics and all that, and you got an idea about testing. So the whole idea of arriving at a decision, conclusion, whether to accept or reject a hypothesis is a test. That is what a test is. So now I told you I need something to decide. That's called as the test statistic. That means I will calculate something. I have taken samples, I have taken some readings, Now from these readings, I will try to calculate some parameter. and that parameter will indicate to me whether I have to accept or reject. I can give you one very simple things. A student has to pass, I mean this is not a hypothesis for you to get what is the meaning of a statistic. A student has to pass a particular course. So, what is my statistic there? Test statistic, the marks obtained should be greater than 50 or more. That is my test statistic. So, if it is a test statistic, pass the student is my hypothesis. So, my statistic is 50. If my value I get of the sample is more than 50, I pass, less than 50, I fail. Clear? So, a test statistic is a parameter you will calculate not arbitrarily, but from the data you have collected, and this parameter will tell you whether you have to accept or reject a hypothesis which is your null hypothesis. It is always the null hypothesis I work on. Do I accept or do I reject the null hypothesis? Clear? So, a hypothesis test is typically specified in terms of a test statistic which can be considered as a numerical summary of a data set. So, I have calculated the heights of some 40 people, I have taken the height, right. So, 40 samples I have, I will reduce it to one number. That is what this means. As a numerical summary of a data set, what is my data set here? My data set is all the 40 heights. As a numerical summary of the data set that reduces the data to one value. It could be the mean, it could be the median, it could be the standard deviation, it could be anything, or we will be defining some more parameters. That can be used to perform the hypothesis test. It is selected or defined in such a way as to quantify, because it is a number. Okay, it is a number, so you have to quantify. To quantify within the observed data, no unobserved data, whatever data you have collected, either through experiment or through a questionnaire or through a survey or through an interview, everything in quantity form, behaviors that would distinguish null from the alternative hypothesis. So, you should have a clear distinction between the null and alternate hypothesis. For example, if your hypothesis somebody is moderately happy, what does it mean? The person is also moderately sad. But when you say, well, the person is very happy, you are excluding sad, right, that is the meaning. So, you should have evidence very clearly for or against. If you are taking a court case, you have all the evidence, you can't say after the evidence, I am not able to prove, I do not know whether they are guilty or whether the criminal is guilty or not guilty. I feel the criminal is guilty, but evidence is not showing that. That is what good criminals do, no? They hide the evidence in such a way that you look at the evidence, you will not get any proof of their guilt. So, the evidence you collect, that is the data collection. You remember how many times I stressed about the method of data collection, sample size, etc. So, where do I get the evidence? The evidence I get from the data I collect. So, the evidence collected from the data should very clearly distinguish between the null hypothesis and the alternative hypothesis. So, in all the tests we are going to see some 3 or 4 important tests, right. In all those tests, we have something called as, it is a number, right, one number, the entire data set I bring it down to one number, and so I am going to define a critical value, which is a value on a, it is a value on a particular scale of the test statistic, beyond which we reject the null hypothesis. So, beyond which means it could be either less than or greater than, depending on the type of test and the type of hypothesis, and it is derived from the level of significance. So, the level of significance is used there. If the test statistic is lower than the critical value, we accept the hypothesis or else reject the hypothesis. Lower or higher, it will depend on what type of test you do, because in negative values, higher the magnitude means lesser. right. So, we will just see what it is. Okay. So, there you have a critical value. Now, when we do the tests, you will understand what it is. So, now you got an idea of the hypothesis testing. So, you can easily see the logical steps for hypothesis testing. First, set up a hypothesis, both null and alternative. Next, set up the significance level, 5%, 1% are what are commonly used. Determine a suitable test statistic, that will depend on what type of tests you want to do, which we will be seeing now. Determine the critical region. So, the region is where the values of the test statistic are whatever you get one value from your data set. No? So, that is called as the test statistic. So, that is acceptable. The region in which it is acceptable is called as the critical region. If it falls outside, it is not acceptable. So, determine that. Then whatever computations have to be done, perform the computations and then give your decision. Decision is accept H naught or reject H naught, that will be your decision. And automatically if you accept H naught, HA is rejected. If you reject H naught, HA is accepted. They are mutually exclusive, they both can't occur. Now, we will just see the steps briefly before we move on to the tests. Set up a hypothesis. So, the first step is to establish the hypothesis to be tested. We saw what a hypothesis is. It is an assumption about the value of some unknown parameter, and the hypothesis provides some numerical value or range for the parameters. So, normally this hypothesis testing is, since it is statistical, it is all deals with quantitative parameters. We do not deal with quality. Here two hypotheses about the population, the null and alternative hypothesis are proposed. That is the first step. And the second step is set up a suitable significance level. So, once you fix your hypothesis, you see what danger a type 1 error will do. Based on that, you set up your significance level, right. So, that is the second step. The third is determine a suitable test statistic. So, when we do the tests, we will see which type of test, like you have a Z test, a one-tailed, two-tailed, a t-test, a chi-square test and so on. So, we will see which test is suitable for what parameters. And then determine the critical region. Before the samples are drawn, it must be decided which values to the test statistic will lead to the acceptance of H naught and which will lead to its rejections. The values that lead to rejection of H naught is called as the critical region. That you can get from tables, standard tables are there depending on the type of test you are going to do. And then performing the computation. Once the critical region is identified, you compute several values for the random sample size, then we apply whatever formula you need for the test statistic and check whether the sample results fall in the acceptance region or the rejection region. Just see whether it falls in the accepted. Sample means not one here, the whole sample you have collected. Maybe you have collected data from 50 people, 1000 people, you have conducted the experiment 1000 times, whatever. And then finally, the decision making. It involves either accepting or rejecting the null hypothesis. Okay. This will depend on whether you are in the critical region or outside the critical region, what is the significance level you choose. So, in one significance level it may not be accepted, in the other significance level it may be accepted, so on. Clear? So, I think we are very clear. Now, we will move on to the tests. What are the different types of tests we have? So, the first one is what is called as, just give me a second. Yeah, first one is when we are testing for the mean of some sample. Like I said, the average, the mean is 73 years, mean lifespan is 73 years, the mean height is 155 centimeter, the mean weight of people in the age group of 10 months is so much, like that. So, we are testing for the mean. Okay. So, as I said, each type of test has a particular application. So, the first one what we are going to see is testing for the mean. Here we have two types of tests. One is called as two-tailed and the other is called as one-tailed test. So, what is two-tailed is, I make a hypothesis of the mean. Okay. So, I will say the average lifespan is 73 years, that is my hypothesis. Mean, average value is mean, and I reject the hypothesis if the average span is either lesser than or greater than. Now, you see why it is two-tailed. So, I have a hypothesized mean, right, I have a hypothesized mean and I reject it if the sample mean. So, how do I determine the average lifespan is 73 years? I will take the data of say 1000 people, that is my sample. I find the average lifespan of my sample of 1000 people. Let us say it will not be exactly 73 because you have a significance level, no, right. So, I reject it if it is either less than 73 or greater than 73. It is two-tailed, it can be on either side, less than or greater than the hypothesized mean. So, the sample mean is significantly higher or lower than the hypothesized value of the mean of the population. So, let us say, some data collected, somebody says the average lifespan of Indian males is 73 years. Now, this could be very different from state to state, state to state. So, I will say this is my population mean. Average of all the men in India is 73 years. Some government record, something they have, they declare it. Okay. Now, I want to see whether people living in hilly areas like say Darjeeling or Shillong, whether it is lesser or how does it compare to somebody let us say who lives in an urban city where there is a lot of pollution. Does the average lifespan reduce because of diseases we get because of pollution and so on, right. So, I have two means here. One is the population mean, and my hypothesis will tell that my sample mean is equal to the population mean generally. So, what I do, the average lifespan of Indian male is 73 years. So, my hypothesis would be, null hypothesis would be mu is equal to 73, mu means average, mean is 73. That is my hypothesis. Now, when I come to Bangalore, I choose some 1000 people randomly from Bangalore. I find that their lifespan is 77. It could be because of better medical facilities here. And maybe I go to some rural area in Karnataka, and then I find that the average lifespan is 67. Okay. So, whether greater than or less than, I will reject the null hypothesis. That is a two-way test, two-tailed test. So, when the null hypothesis is some specified value and the alternative hypothesis is a value not equal to the specified value, then you use what is called as a two-tailed test. So, what will my hypothesis look like? H naught, mu is equal to mu of H naught. That is the population mean, population mean. So, I am saying the mean of my sample is equal to the population mean, that is called as a mu of H naught. You can use any other symbol also, no problem. Understand what we are doing. My hypothesis is my sample mean is equal to population mean. And my alternative hypothesis is it is not equal to, that is all. It can be greater than or lesser than, I am not committing. So, it is two-tailed. So, I will have two critical areas, one for greater than and one for less than. So, if it falls in either of the critical areas, I reject the null hypothesis and accept the alternative hypothesis. So, the two-tailed gets its name from the testing area of a normal distribution. So, we will see one test. Normal distribution is what I showed you. A normal distribution is one where the mean, the mode and the median are all same and the data is dispersed equally and it is continuous, right. So, one of the first tests, simple test to administer, what we see is called as the Z test, and my assumption here is that the data is normally distributed. The data is normally distributed, which is true for most of the physical parameters. So, now I told you what we do. I calculate what is called as a Z score or a Z factor or a Z value. How we define it, we will see. I quote it. I calculate, not quote, I calculate. I calculate a Z factor, a Z score or a Z value with what? With my sample population. I calculate it with my sample population and I compare it, because remember this test is for means. I compare it with the total population mean or my hypothesized mean. I may not have a total population mean, I will hypothesis, some hypothesis I will have, I will compare it with that. So, what am I comparing? I am comparing my hypothesized mean with a Z value. Then if this Z value is in a critical region, I reject H naught. If it is in an acceptable region, I accept H naught. How do you know whether it is critically, whether it is in the critical region or not? You will see it in my next video. Okay. Thankfully, you do not have to do it. Statisticians have done it and they give us a beautiful table. You just have to look at the table and take a decision. Thank you.